In the process equipment design 2 subject, we are discussing a new chapter, that is process design in the reaction vessel. Okay, so we discussing in the previously, that is uh, storage tank design. So in that chapter we discussing how to uh, first we consider what is storage tank and which types of storage tanks are useful for industrial as well as small scale. Then after the types of storage tank we classified, okay, based per the APA standard 620. Then we design storage tank. Also we discussing the conical root storage tank. Okay, so now next unit is the reaction vessel design. So from the title of the chapter we know that the now it's time to design a reaction vessel where the reaction can take place. It should be various types of vessels, reaction vessel we need for the complete the reactions. Okay, so which types of material we required, which types of agitations, which types of pedal, so numbers of parameter will be considering for the reactions vessel design. Okay, so reaction vessel क्या है, first of all the normal introduction is given that. Okay, so most of the batch reactors and many continuous reactors are provided with agitators. So agitator, you know that agitator is, it is used to mixing purpose, or it will be the uh, complete mixture, do the complete mixture, and it will be very helpful to complete the chemical reactions. Okay, so most of the batch reactors and many continuous reactors are provided with agitators. Most of the batch reactors and many continuous reactors are provided with agitators. It consists of agitators, and agitators are provided in the reactors to improve mass transfer rate and heat transfer rate. Okay, as per, so basically it is what for purposing mass transfer and heat transfer. It is the basically it will be helpful to the reaction, overall reactions. Okay, सो वो क्या कर रहा है, मास ट्रांसफ़र रेट है. ओके, मिक्सिंग के लिए, और इट विल बी अप्लाइंग अ हीट ट्रांसफ़र एज वेल. So the overall rate of reaction is controlled by the rate of mass transfer and the rate of chemical reactions. Okay, total rate of reaction is controlled by rate of mass transfer as well rate of chemical reactions. For many reaction, if mass transfer rate is poor, then time required for the complete of the reaction would be more. Okay, so as any reactions, it is important to that mass transfer rate should be very high, because of to the mass transfer and the heat transfer, it becomes the entire reaction should be very fast. But if any in the reaction mass transfer rate should be low. Okay, that means what I say that if there is a reaction vessel, if we are not using the reaction agitator. Okay, so what exactly do, the mass transfer rate should be low and it becomes more time to complete the reactions. Okay, so normally it will be used the use the agitators. Normally we design for the reaction such effect of mass transfer rate on overall rate of reaction is nullified. For example, say that we carry out some gas liquid reaction in laboratory or in a pilot plant reactor. Okay, for example, we carried out some gas liquid reactions. Okay, then it consistent in a pilot plant. So it having a agitator, speed of agitator is 50 rpm. If we increase the speed of agitator is 50 rpm to 100 rpm, so as the result is that the time required for the completion of the reaction is reduced. It is simply said that અગર હું 50 આરપીએમ સ્પીડ પર હું મિક્સિંગ કરું છું અને એ જ વસ્તુ હું 100 આરપીએમ પર મિક્સિંગ કરું છું, સો દેટ વિલ બી a major change. Okay, similarly, if I keep the rpm, the speed of the agitator should be 200 rpm, so it compared to the 1500, it will be the more, and the mass transfer rate should be very high. Okay, so for the entire process, entire mass transfer reaction, the agitators is the main role to play to complete reaction fast. So let we check and the different types of agitators. So next point is that our point is that different types of agitators. Agitators are having a type, many type. So which is mainly three types of agitators are important for propellers, pedals and turbines. Okay, so it will be different types. First, propellers, pedals and turbines. So propellers should be which types of it, like say in the figure 5.1, it is a marine type a mixing propeller which is used in the marine submarines, as well as submarines, as well as in a fan, boat or other things. So first is that propellers. So propellers should be seen the figure 5.1 look like that, which is having a three blades. Okay, and which is propellers are generally axial flow agitators. Axial flow, which creates an axial flow. Okay, so propellers, pedals and turbines. First we see the propellers. Propellers are axial flow agitators, which create a flow in the direction that is a axial flow only. Propellers are having a tapered blade. Propellers are having a tapered blade which minimize the effect of the centrifugal force and hence minimize the radial and tangential currents, and it produce the maximum axial currents. It produce maximum axial currents. Okay, so directly you can type a Google in which what is the axial flow and radial flow, so you can easily understanding about the axial flow and radial flow. So I told you that what is axial flow. Axial flow is created only the surface where the reaction, where the blade is put into the reaction. Okay, and the molecules are in the circulatory forms, mixing in the circulatory forms, where the in the radial flow, radial flow radial flow, that means the flow pattern is created in the entire reaction wall. Okay, entirely reaction के अंदर आपको उस molecules mix होता रहेगा. ठीक है. Generally the speed of the smaller propeller is 1150 rpm to 1750 rpm. 1150 आरपीएम से लेके 1750 आरपीएम तक स्पीड रहती है नॉर्मल प्रोपेलर की, स्मॉलर स्पीड. देन स्पीड ऑफ लार्ज प्रोपेलर, सो डायमीटर if it should be 1 feet, if the propeller it having a diameter of 1 feet, more than 1 feet, it will be the speed of the rpm is then 400 to 800 rpm. Okay, जैसे जैसे diameter should be very large, the speed is reducing, and if the diameter of the propeller it should be very small, then the speed of the propeller should be more. Okay, a tip velocity of the propeller is between 300 to 500 meter per minute. Tip velocity, which is given by u is equal to 2 pi rn. Diameter of propeller is between 15 to 13 percentage of the tank diameter. What is the propeller diameter we should kept? The tank diameter जो होता है, okay, उसका 15 से 30% के बीच में हम डायमीटर रख सकते हैं. It can be directly coupled to a standard electric motor. Propeller creates the current in the axial direction in one revolution of propeller. It moves the liquid in the axial direction to a particular distance. As per I told you, it axial direction ની અંદર જ એક કરંટ ક્રિએટ કરશે. The ratio of this uh, distance to the propeller diameter, it is known as a pitch of propeller. ઓકે, અને જે આ ડિસ્ટન્સ છે એને શું કહેવામાં આવે છે? પિચ ઓફ ધી પ્રોપેલર. Propeller with a pitch of 1 is said to have a square pitch. જે રેશિયો, કયો રેશિયો? કે જે એક્સેલ ડાયરેક્શનમાં જે એજિટેટર મૂવ થાય છે, અને બીજું છે કે જે ડિસ્ટન્સ, ઓકે, ધ રેશિયો ઓફ અ ડિસ્ટન્સ પ્રોપેલર ડાયામીટર ઇઝ નોન એઝ ધ pitch of the propeller. અને આ પ્રકારના જે હોય છે એને કહેવામાં આવે છે સ્ક્વેર પિચ. And the standard three blade propeller with a square pitch is most widely used in the industry. So there is an show in figure which is mainly used in the industry. Okay. Next is propeller can be used to mix the immiscible liquids having a low medium viscosity. Propellers generally used for what purpose? To mix the immiscible liquid which is low medium velocity. It can be used for a slurry. If solid concentration and viscosity of solution is less, they are not normally used for a gas liquid reaction as for the gas liquid mixing. They are not used gas liquid reaction for a mixing of gas and liquid. Radial and tangential currents are more important than axial currents. Okay, કારણ કે જે એક્સિયલ ફ્લો જે કરંટ છે એ ઓનલી એની એક્સિસ અને જે સાફ્ટ છે એના આસપાસ જ ક્રિએટ કરે છે, અને ફ્લો પેટર્ન જે છે એ રેડિયલ ફ્લોની અંદર શું થાય છે? એન્ટાયર રિએક્શન વોલની અંદર ક્રિએટ થાય છે, જેથી કરીને એ ખૂબ જ અગત્યનું છે. બરાબર ને? સો ધીસ આર ધ મેઇન ડિફરન્સ બિટવીન એક્સિયલ ફ્લો એન્ડ રેડિયલ ફ્લો. ધ ફ્લો પેટર્ન્સ આર ડિફરન્ટ. Gas itself creates the axial current. Gas is create itself axial current. So it is provided to better mass transfer. We have create tangential and radial current, so that can be obtained with the flat blade turbine agitators. Okay, જે ગેસ હોય છે એ શું કરે છે? ખુદ પોતાની જાતે જ એક્સિયલ ફ્લો કરંટને ક્રિએટ કરે છે. તો એના માટે ફ્લેટ બેડ ટર્બાઇન, વેરિયસ ટાઈપ્સ ઓફ ટર્બાઇન ઇમ્પેલર શુડ બી પ્રોવાઇડિંગ. ઓકે, સો એના માટે આ પ્રકારના શું કરવામાં આવે છે? ટર્બાઇન ઇમ્પેલર્સને ડેવલપ કરવામાં આવેલા છે. Now, so as per we show in figure, which is a pitch bed turbine, which is a radial flow, flat blade turbine for which is axial flow. This is also a curved blade turbine, okay, which is an axial flow. Anchor impeller, which is an axial flow. Okay, so these are the different types of impellers. First one is pitch bed, second one is flat bed turbine, third one is curved blade, and fourth one is anchor impeller. The propeller can be used for agitation of homogeneous liquid in reactor smaller in a volume than 3.8 meter cube. Propeller ક્યાં યુઝ કરવામાં આવે છે કે જ્યાં વોલ્યુમ 3.8 મીટર ક્યુબ અથવા તો એના કરતાં ઓછું હોય, લેસર ઇન ડાયામીટર લાઇક 1.8 meter, where less than 2.2 kilowatt, that means 3 horsepower is sufficient for desired process result. ઓકે, જે એજિટેટર છે એની અંદર પહેલું તો કે વોલ્યુમ 3.8 મીટર ક્યુબ હોય અથવા તો ડાયામીટર 8.8 મીટર કરતાં ઓછું હોય, અથવા તો એ એ જે છે બરાબર, એનું જે પાવર કન્ઝપ્શન છે એ કેટલું હોય છે, 2.2 કિલોવોટ કરતાં પણ ઓછું હોય છે. નેક્સ્ટ lecture we discussing pedal agitators.